Hi friends, so today we are going to learn about gravitation. Now everyone knows that gravitation was discovered by Sir Isaac Newton, right? Now we know the story about it, let's have a look at it again. Sir Isaac Newton was sitting under an apple tree when suddenly an apple fell down. Newton started thinking that why does the apple fall down? Why doesn't it went horizontally or at some angle? So he came up with the concept that the earth might be attracting the apple towards itself. So he decided to give that force a name, that is what we call as gravitation. Now he also observed that whether the apple is at the bottom of the tree or at the top of the tree, it falls on the ground in the same direction. Hence, he concluded that all the objects, even at different heights, get attracted towards the earth in the same direction, that is perpendicular to the surface of the earth. Hence, the distant objects such as moon as well should be attracted towards the earth. Now, prior to Newton, there was a German astronomer, Johannes Kepler. He has made immense research in studying the planetary motions or the positions of different planets and its satellites. But his research was completely based on observation and there was no mathematical proof for it. Newton had no idea that these Kepler's laws would be helping him to state the most important universal law of gravitation. Now, before moving on to the Kepler's law, one should understand a basic important concept of the rotational motion. Now, what is it exactly? Let us have a look at it. Now, imagine yourself holding a string in your hand which is tied to a stone or a heavy weight at the end, and you are moving the string in a circular direction as shown in the figure. Now suddenly, while in motion, if the string gets detached from the weight, then the weight actually moves out of the circular path and goes straight, tangentially, right? So this means while the weight was in circular motion, there was some force which was attaching it to the center of the circle. That force is called as the centripetal force. Now, with this understanding of centripetal force, we can now move on to seeing the Kepler's law. Okay, Kepler's has placed his laws, but those laws was without any proof. He just made these laws using his observations, and hence it helped Newton to get on his own law of gravitation using the Kepler's concept. Now let us have a look at three laws of Kepler. The first law states the orbit of a planet is an ellipse with the sun at its foci. Now, an ellipse, everyone knows what a circle is, right? Now, if you press a circle from two opposite sides, the shape which we get is an ellipse. Now, a circle has a single center, whereas the ellipse has two. But they're not called centers. They are called as focus. And plural word is foci. The first law states that the orbit of a planet is actually an elliptical orbit and the sun is at one of its foci. Okay, the second law states that the line joining the sun and the planet sweeps an equal area in equal intervals. Now imagine the planet is moving around the sun. Now suppose it covers a particular distance in a particular time, say 1 month. So if we note the distances from A to B is 1 month, from C to D is 1 month, from E to F is 1 month, right? So there are three distances which are covered in the same interval of the time. Now if we join that distance with the center, that is the sun, the area which we will get in all the three portions will be equal. Okay, now the third law. The third law states that the square of its period of revolution around the sun is directly proportional to the cube of the distance of the planet from the sun. It means the square of the time required for one revolution of the planet, that is denoted by T. Okay, for Earth the T is 1 year. The same way for each planet there is different amount of time which is required to complete one complete revolution, and that is directly proportional to the cube of the mean distance of the planet from the sun. Okay, so more the distance, the more the time required for one revolution. Now these were some basic laws of Kepler, which are very important because Newton used these concepts to state his basic and very important universal law of gravitation. Now let us have a look at what is universal law of gravitation. It states every object in the universe attracts every other object with a definite force, and this force is directly proportional to the product of the masses of the two objects, and it is inversely proportional to the square of distance between them. It means if there are two objects m1 and m2 at a distance of d between them, then each of these objects attract each other with a force, and the magnitude of that force is directly proportional to the product of the masses, that is m1 and m2, and inversely proportional to the square of the distance between them, that is d square. Okay, now to remove the proportionality sign, I need to take constant of proportionality. So F is equal to G into m1 into m2 upon d square, where G is the universal gravitation constant, and the value of G is 6.673 into 10 raised to minus 11 Newton meter square per kg square. Now if you have a careful look at the equation, you can see that if the mass of one of the object is doubled, the force between the objects also doubles. Okay, and if we triple the mass of any object, then the force also becomes 3 times. Also, it is important to note that if we increase the distance between two objects, okay, if we make the distance 2 times the original distance, then the force between the two objects decreases by the factor of 4. So next time we will be seeing what is the relation between the Kepler's law, the centripetal force, and universal law of gravitation.